Hello, people, and welcome back to another session. In this session, we'll be starting off with a new topic. We'll be starting off with one-way analysis of variance, or what is also called as ANOVA. Now, one-way analysis of variance, or ANOVA, is useful whenever we have to find information with respect to groups using a particular factor. To extrapolate the application of ANOVA, basically, when our goal is to compare different groups and to find out differences between those groups or similarities between those groups, we use one-way analysis of variance. Now, the fundamental idea in one-way analysis of variance is that what one-way analysis of variance aims at doing is if we have a set of data points like this spread out in space. The goal of one-way analysis of variance is basically to identify which groups are similar and which groups are different. So, to describe further, when you come across a scenario where you need to basically observe how many different groups exist in a particular population set. For instance, let us say that you have a social media data set with you. And in social media data sets, one of the most recurring themes is to identify groups of people who are heavily interacting with one another. And those groups of people are going to be considered within a single group or a single cluster. This is just one of the many applications of one-way analysis of variance. Now, in a typical social media data setting, what you have is basically something called as a graphs data set. In a graph, or not a graphs data set, basically the data set represented through graphs, or let's just say trees in general, where what you see is there are groups of users in a network, and these groups are connected with each other through a branch. So this is one of the examples of one-way analysis of variance where we basically try and identify different groups. Moving forward, how do we actually measure what groups exist, or how do we actually go ahead and identify groups that exist within a population data set? The way to do that is basically to find out variability. And variability is a measure of how distinct the points are with respect to one another. Variability has to be calculated within each group, and variability needs to be calculated between groups. So if you look at this particular arrangement of data, what you can see is variation between data points within this particular circle. This is extremely small. The variation here is extremely small as compared to the variation between a black point and a red point, a pink point and a black point, or a red point and a pink point. So let me reiterate the idea once again. In order to find out, or in order to identify distinct groups within population sets, we need two measures. The first measure is variability within each group, and the second measurement is variability between groups. If the variability between groups is much higher as compared to the variability within the groups, then we can clearly surmise and say that our groups in this situation are actually different from one another. If that is not the case, however, then we cannot say that the groups are different from one another. As we'll move forward and we'll see more examples, this idea will become more and more clear to you. But essentially, this measure of variability or this idea of calculating variability is something that we do using one particular factor. And in most cases, that particular factor is the mean of the groups. So let us go ahead and understand a few mathematical concepts. So as I was telling you, our goal with one-way ANOVA is to find out the distinction between groups that exist in a population data set. So for one-way AOV, and because the measure of variability is the mean, so for one-way AOV, our null hypothesis is that my mean of first group is equal to my mean of second group is equal to my mean of third group, and so on. So the idea here is that if the measure of variability of all the different groups are the same, then there is no distinction between the groups and all of them are basically the same. The alternative hypothesis here will be that if my mean of ith group is not equal to my mean of jth group, then it means that the measure of variability of the ith group and the jth group is different, and therefore we can surmise that these two groups are actually different from one another. How do we do this? How do we actually perform the hypothesis testing? Well, for that you need to know some basic mathematical terms used in the hypothesis testing or statistical inference of one-way ANOVA. So let's go and discuss each of them. Actually, I'll keep this. So for this particular test, or basically to perform statistical inferencing on this hypothesis, we need a test statistic. And here, for this particular test, our F statistic value will be equal to SB square upon SW square, which is nothing but mean square between upon mean square within. So mean square of between the groups and mean square within groups. This is the value of my test statistic or F statistic. Now, how do I calculate the mean square between and mean square within? Well, you know that from our previous discussion on ANOVA table, the value of mean square is equal to the value of sum of square divided by the value of degree of freedom. So this can be defined as sum of square between divided by the degree of freedom of mean square between, which is k minus 1 divided by sum of square within divided by n minus k. Here, k represents the number of groups and n represents my total number of observations. Okay. Now, this is how I calculate my test statistic for to calculate or basically to find evidence against this null hypothesis. Now let us see how to calculate sum of square between and sum of square within. Now let us suppose you have been given a data set, and in that data set you have been asked to calculate what is the value of my sum of square between and my sum of square within. You have been given n number of groups, you have been given the data points for each of the groups, and you have to calculate sum of square between and sum of square within, right? So let us dive into it. If I need to calculate sum of square between, basically what I'm trying to calculate variability between groups, right? So how will I do that? I'll do that by calculating summation of right? This is how I'm going to be calculating the value of my sum of squares between. This is this term xj bar represents mean of group J. And this x bar dot dot, this represents mean of data set. Okay, so basically how do you calculate sum of square between? This nj represents the number of points in each group. This represents my mean of the group, and this term represents my overall mean. Okay, this is how you calculate your sum of squares between. To calculate sum of squares within, you have to basically take double summation. So this is how you're going to calculate your Sorry, this is how you're going to calculate your value for sum of square within. Now, basically, why I have put a double sum over here? I put a double sum over here because this has to be I. Yeah. So let me rewrite this actually. So there is a double sum over here because you have to, for each group, you need to calculate the difference between the point and the group mean, square them and add them, and you need to do that for all the subsequent groups. Please try and understand this point. This is a very important point. What you have to do here is you have to first calculate the the square of difference of each individual point from the group mean, and at the same time after that you need to do it for each group separately. So if suppose each group has n points and there are k groups, this is how you calculate your value of sum of squares within. So this is an overview of how do you calculate the F statistic value in order to proceed with the hypothesis testing of finding out differences that exist between groups in a population, which is also the idea of one-way analysis of variance. Now, to actually have better clarity or more idea, in the next session, we'll go over a sample example to implement whatever we have learned in this particular section. Thank you so much for watching. I'll see all of you all in the next session where we'll be discussing this example.